All right, let's look at this example now. Okay, this one's same concept, but a little bit different because what we've been given is a little bit different. So once again, I want to solve this triangle. So I want to find angle G, I want to find angle H, and I want to find angle J. Okay, then I also want to find side G, side H, and side J. All right, well, angle J is 90 degrees. Angle H is 25 degrees. And then angle G we don't know, but we can find out. So the key here is you're going to be given three things. Let's go ahead and write down the third thing we're given. We're given that side J is 13. Okay, rule of thumb is you're probably going to be given three pieces of information. And with those three pieces of information, the easiest thing is going to be to find what you have two of already. So if you have two angles, finding the third angle is going to be the easiest. If you're given two sides, finding the third side is going to be the easiest. Okay, so we have two angles here, so I can find angle G, and I can find angle G because we know that these three form a triangle and they all have to add up to 90 degrees. So I can, or 180 degrees. So I can say 180 equals 90 plus 25 plus angle G. So 115 equals angle 3. Oh, 115 plus angle 3 equals 180. Minus 115. So I get 65 equals angle 3. So this is 65 degrees. Okay. All right, now it's back to what we've already learned from 9495 Part B to find the other side. So I'm just going to pick an angle and make it my reference angle. I don't know, I'm going to make angle H my reference angle. You could have made angle G too. Okay, and I want to solve H by itself. Okay, I want to solve H first. And you can solve for G first, it doesn't really matter, but I'm going to solve for H first. So if I let angle H be my reference angle, this is my opposite side, this is my hypotenuse, and this is my adjacent. Okay, so I want my opposite, I know my hypotenuse, so if I write TOA, I want my opposite and I have my hypotenuse, so I have O and H. Okay, well, O and H is right here with sine. So I'm going to use the sine of theta, or sine of 25 degrees, equals, well, sine is opposite over hypotenuse, so it's going to be H over 13. Okay, now I want to get H by itself, which is pretty simple. So times 13, those go. So I have 13 times sine of 25 degrees equals H, and then all I can do is put this into my calculator. My calculator knows the value of sine of 25. So 13 times sine of 25 gives me roughly 5.5. So my H is about 5.5. Okay, now you could use Pythagorean theorem, or you could use this again. I would not use Pythagorean theorem, and the reason I wouldn't is because this here is rounded. Okay, and in order to use the Pythagorean theorem, we would have to use this number. So remember that if we round any number, the more times we use it in calculations, the bigger that error gets. Okay, so without using Pythagorean theorem, I want to find G. So I'm looking, and once again, if I don't have to use this rounded side, I'm not going to. I can use it. It'll give me a good ballpark figure. But I'm looking for my adjacent side, and I know for sure my hypotenuse, and this isn't rounded. So if I look up at these trig functions, I have H in my A, and I can see cosine right here. So cosine of theta is A over H, and that's exactly what I want. So I'm going to use cosine in 25, still my reference angle, just because I chose that one. You could have chosen the other one. Cosine of 25 equals, well, A, that's my unknown G, over H, which is 13. Okay, multiply both sides by 13. Remember, we always want to get rid of that denominator. So that goes away. So 13 times cosine of 25 equals G, and our calculator knows what cosine of 25 is, so 13 times cosine 25 in our calculator, I get roughly 11.8. So G is roughly 11.8, and we have solved the triangle. All right, I want you to use the example we just did and go ahead and try this one on your own. All right, this one here, I first went and I found the third angle since I was already given 2, so I got angle Y is 38 degrees, okay? Now, I have 2 sides that I needed to find, and you can pick which one you want to find first, but what we want to make sure of is that we're going to use our adjacent side, since that's the only one we have, to find both of these. So if I put SOHCAHTOA, cosine and tangent both have adjacent, sine does not, so we're not going to use sine. Okay, so I can say the cosine of 52, and cosine is adjacent over hypotenuse, and the adjacent is 8.5. So 8.5 over my hypotenuse is z. Like always, I want to multiply my z to get rid of the denominator, so I get z times cosine 52 equals 8.5, and then I want to divide by cosine of 52 to get z by itself, and I get z is roughly 13.8 when we round. Okay, same thing to find my x. I'm going to use tangent, and like I said, you could have done tangent first to find x and then cosine to find z. Tangent 52 equals, tangent is opposite over adjacent. Opposite is x. Adjacent is 8.5. So when I multiply by the denominator, I get 8.5 times tangent 52, and that's going to equal x. So x is roughly 10.9. All right, let's look at this final one, this word problem, and then we'll be done. So it says your school is building your raked stage. The stage will be 30 foot long, so this top here is 30 foot, from front to back with a total rise of 2 feet. So it's going up 2 feet. You want the rake, which is the angle of elevation, to be 5 degrees or less for safety. So this X, for safety reason, has to be 5 degrees or less. And we want to know if this in fact satisfies those requirements. Okay, so I basically want to solve for X here. All right, so once again, anytime there's a picture, I draw it separate just to kind of help myself out. So 32, this is X degrees. Okay, if I want to go and label opposite, hypotenuse, and adjacent, I know my opposite and I know my hypotenuse. So SOHCAHTOA. So notice which one pairs opposite and hypotenuse together. That's my sine. Okay, so I can say the sine of whatever angle X is going to equal, well, sine is opposite over hypotenuse, so 2 over 30. Okay, I want to find the angle measure, so that tells me I'm using the inverse. So I want to do sine inverse, and when I do sine inverse, these flip. So sine inverse of 2 over 30 is going to equal X. Okay, and then I just put that on my calculator. Inverse sine of 2 divided by 30. I get X is roughly 3.8 degrees. And if I compare that to 5 degrees, yes, this satisfies our requirement because 3.8 is less than 5.